Have you ever gazed up at the night sky and wondered if we're alone in the universe, or if there's life on planets beyond our solar system? This thought has captured human imagination for centuries and is now a central question in the field of astronomy. The answers may lie in the distant worlds known as exoplanets, planets that orbit stars outside our solar system. These celestial bodies, each with unique atmospheric conditions, offer tantalizing possibilities for the existence of extraterrestrial life. Scientists are now harnessing sophisticated technology to probe the atmospheres of these exoplanets, seeking clues about their potential to harbor life. It's like a cosmic detective story, where each piece of evidence brings us closer to answering the age-old question, are we alone? But before we dive into the intriguing methods scientists use to study these distant atmospheres, let's first understand what an exoplanet is. Simply put, an exoplanet is a planet that orbits a star outside our solar system. These cosmic bodies, hidden in the farthest reaches of space, are as diverse as they are numerous, from fiery gas giants larger than Jupiter to small rocky planets that could fit in the palm of your hand. Exoplanets come in all shapes and sizes. Some are scorching hot, with temperatures that could melt lead, while others are icy realms where even the air freezes solid. There are trillions upon trillions of these exoplanets in the universe, each one a potential clue in our quest to answer one of humanity's most profound questions. Are we alone in the universe? The discovery of these planets has opened up new avenues of exploration and sparked our imagination. So how do scientists study these distant worlds to determine their potential for supporting life? That's where the science of exoplanet atmospheres comes in. The study of exoplanet atmospheres is a complex process that involves several steps. So let's dive into it, shall we? At the heart of this process is a technique known as spectroscopy. In simple terms, spectroscopy is the study of the interaction between matter and electromagnetic radiation, in this case, light. But how does it help us understand the atmospheres of exoplanets, you ask? Well, imagine an exoplanet orbiting its parent star. As the planet passes in front of the star, some of the star's light filters through the planet's atmosphere. This light, carrying the fingerprints of the atmosphere, eventually reaches our telescopes. By analyzing the spectrum of this light, scientists can identify the unique signatures of different elements and compounds in the planet's atmosphere. Think of it like a cosmic barcode. Each element or compound in the atmosphere absorbs light at specific wavelengths, creating distinct patterns in the light spectrum. These patterns serve as a unique identifier, much like a barcode, that can be used to determine the atmospheric composition. For instance, the presence of oxygen and methane in an exoplanet's atmosphere could suggest the possibility of life. Why? Because on Earth, these gases are produced by biological processes. Similarly, the detection of water vapor could point towards the potential for liquid water, a key ingredient for life as we know it. However, it's not as straightforward as it sounds. There are numerous factors that can influence these readings. For instance, the size and temperature of the star, the distance of the exoplanet from its star, and the exoplanet's own temperature and atmospheric pressure can all affect the spectral data. Despite these challenges, the study of exoplanet atmospheres is an exciting field that holds the promise of unlocking the secrets of distant worlds. It's like piecing together a cosmic puzzle, where each piece of data brings us one step closer to understanding whether we are alone in the universe or not. But how exactly does this process work? And what does it tell us about the possibility of life on these planets? Well, stay tuned to find out more in the next episode. Scene script. Spectroscopy, in essence, is the science of light, a tool so powerful it allows us to decode the cosmic secrets held by the distant exoplanets. But how, you ask? Let's delve into the magic of spectroscopy. Imagine light as a cosmic messenger carrying information across the vast expanses of space. When this light encounters an exoplanet's atmosphere, it doesn't just pass through. It interacts with the atoms and molecules present, and this interaction leaves a mark on the light, changing its properties in subtle ways. Now, each element and compound in the atmosphere absorbs light at different wavelengths. Think of it like a cosmic barcode, where each stripe represents a different wavelength absorbed by a different chemical compound. This creates a unique, spectral fingerprint for every exoplanet. But to read this fingerprint, we need to first separate the light into its constituent wavelengths, much like how a prism splits white light into a rainbow of colors. This is where spectroscopy comes into play. It's a technique that allows us to split the light into its various wavelengths and analyze the intensity at each point. The result is a spectrum, a graph of light intensity against wavelength. The dips in this graph, the dark lines, represent the wavelengths where light has been absorbed by the elements in the atmosphere. Each element leaves its unique signature on the spectrum. For instance, oxygen absorbs light at certain wavelengths, and so its presence can be inferred from the corresponding dips in the spectrum. In this way, by carefully analyzing the spectrum, scientists can identify the elements and compounds present in the exoplanet's atmosphere. They can determine whether it contains water vapor, methane, carbon dioxide, or even oxygen. By studying these spectral fingerprints, scientists can make educated guesses about whether a planet could potentially support life. The presence of certain gases, like oxygen or methane, in the right proportions could indicate the possibility of biological activity. And therein lies the power of spectroscopy. It could eventually lead us to the discovery of life beyond Earth. So, what exactly are scientists looking for in these spectral fingerprints? At the heart of the quest to find life beyond Earth, researchers are examining the atmospheres of distant exoplanets for key signs of life, or biosignatures. Let's dive a bit deeper into what these biosignatures are. They are essentially molecules that, based on our understanding of life on Earth, suggest the possible presence of biological activity. The most significant among these is oxygen. Oxygen, as we know it, is a highly reactive gas that gets rapidly consumed in chemical reactions. On Earth, it's continually replenished by plants and algae during photosynthesis, a clear sign of life. If we find an abundance of oxygen in an exoplanet's atmosphere, it could suggest the planet is teeming with living organisms. Another biosignature gas is methane. Methane can be produced through geological activity, but a significant portion on Earth is also created by life, particularly by microbes known as methanogens. If we were to detect methane alongside oxygen on an exoplanet, it would be a strong indication of biological activity, as the two gases quickly react with each other and would need to be constantly replenished to remain present in the atmosphere. However, the detection of these gases alone isn't enough. Scientists also look for a balance of different gases, as life is known to create a state of chemical disequilibrium. For example, a large amount of oxygen alongside a lack of carbon dioxide could indicate life, as photosynthetic organisms consume carbon dioxide and release oxygen. But it's not just about the gases. Scientists also consider the planet's temperature, size, and distance from its star, among other factors. These elements help determine whether the planet falls within the habitable zone, where conditions might be just right for liquid water to exist, a prerequisite for life as we know it. The discovery of these biosignatures could be a game changer in the search for extraterrestrial life. It's like piecing together a cosmic jigsaw puzzle, and each discovery brings us one step closer to answering one of humanity's most profound questions. Are we alone in the universe? So why do we go to all this trouble to study the atmospheres of distant exoplanets? The answer, my friends, is both profound and captivating. By probing these alien atmospheres, we're not just indulging in cosmic curiosity. We're embarking on a journey that has the potential to redefine our understanding of life itself. The study of exoplanet atmospheres holds the tantalizing possibility of discovering extraterrestrial life. Imagine uncovering a world with an atmosphere rich in oxygen or methane, telltale signs of biological activity. The implications would be monumental, affecting everything from our philosophies to our sciences. But it's not just about finding alien life. Studying these distant atmospheres also helps us understand our own planet better. It provides us with a cosmic mirror, reflecting the uniqueness of Earth's life-sustaining atmosphere in the grand tapestry of the universe. As we continue to gaze up at the stars, the study of exoplanet atmospheres brings us one step closer to answering the age-old question, are we alone in the universe?